All right. Okay, so the first one, this is a Bernoulli equation thing, right? Notice that the pressure at Y is greater than the pressure at X because it's pushing that fluid up the pipe. So the first thing I did was I figured out the pressure Y minus pressure X, whoops, is equal to just rho GH, right? Rho G difference in H, right? And the difference in height here is 0.22 meters, right? So you're going to put in 0.22 for that, right? G is 9.81, rho is 1,000, right? Okay. So now you've got Py minus Px, right? Okay, and then you can do Bernoulli's equation, right? So Px plus rho GHX plus 1/2 rho Vx squared equals pressure at Y plus rho GHY plus 1/2 rho Vy squared, right? Okay, now, so if we're just rearranging this, right, the height, they're both at the center, right? So the two heights are the same, yeah? The velocity at Y is 0 because it's running into a dead end there, right? So this velocity is 0. Okay, and then you can throw this this x over here, right? And you end up with 1/2 rho Vx squared is equal to Py minus Px. And this is a common thing, right? If there were two different velocities, we'd just have 1/2 rho Vx squared minus 1/2 rho Vy squared, and it's equal to the difference in pressure. And there could be a height difference or something like that, but this is sort of a common thing here. That's an x, okay? So you figure out what this difference is, right? Plug that in for this side here, right? And then that equals 1/2 rho Vx squared, which is the velocity right here that you're trying to figure out. And you'll get, I got something like a little more than 2, okay? It rounded to 2.1, but they say it's about 2 meters per second, okay? So anyway, that should be good there, right? Okay, and then it says the viscosity of water is that, right? So estimate the Reynolds number, right? Well, the Reynolds number, you're going to use R is, what is it? It's VR times that over the viscosity. Is that right? Verp over viscosity, right? You have the velocity. That's the answer from that question. And if you couldn't get it, you'd use the 2, right? The radius, they give you the radius there. They give you the diameter in the previous problem, so just cut it in half. They give you the density. They just gave you the viscosity, right? Outline whether your answer to A is valid. Well, it's true only if it's not turbulent flow, right? So if the R is less than 1,000, then it could, then Bernoulli's equation applies. If it's turbulent flow, Bernoulli's equation does not apply. Does not fly. Okay, so just look at that Reynolds number. If it's smaller than 1,000, then yeah, it would be valid. If it's bigger than 1,000, then the answer's not terribly valid. Okay.